Okay. So from the homework 5.4, question number 6. We're looking at it here. The lengths of lumber machine cuts are normally distributed with a mean of 88 inches and a standard deviation of 0.5 inches. So before I even read parts A and B, I'm just going to write down what's the given information here. So what they're telling us is about the distribution. So remember that one of the key things I always say for these problems is to make sure that you can describe the distribution. So what do we know about the distribution? First of all, it says the distribution is normal. And then second of all, there's a mean of 88 inches. So mu equals 88. And there's a standard deviation of 0.5. So sigma equals 0.5. Okay. For anyone just showing up, we just got underway with this question, so no worries. Okay. So now I've just written down the given information in notation that I can use to do the calculations. Okay. So, and in fact, what I have already, we can turn this into a picture. So the picture is, here's a normal distribution, and we're going to have z-scores, and up here, you know, the area and probability, we think of it as the same thing. Okay. And the z-score in the middle is always 0. Okay, so now let me read question A. Question A, what's the probability that a randomly selected board cut by the machine has a length greater than 88.13 inches? So in notation, what that's asking is what's the probability? They might write it as capital P, I like to write out prob, that a randomly selected board, so that's one data value, that's X, is greater than 88.13. Okay, so we know we also have to look at X values, and we know that the value, so for X values, what goes in the middle of the distribution is the mean, and we already know that the mu is 88. And now this question is asking us about 88.13, so I got to mark that value off. And then it says greater than. So what we're interested in is blah, blah, blah to the right. Okay. So now that's the setup of all the given information and what the question is. And then from here, we got to do our calculations. So since we're given an X value and we need a probability, I always like to say we have to go up the ladder. So first, you have the X value. So you got to find the z-score, and then you're going to find your area / probability. Okay, so let's find the z-score. So z equals X minus mu over sigma. Okay, the X value of interest that we're dealing with is 88.13. The mu was 88, and the sigma we were given, that was 0.5. So now you just need to punch that into a calculator. So I'm going to do that right now. Okay, so work that out and you get 0.26. So there's your z-score, 0.26. And now we have to convert that into a probability. Okay, so I'm just gonna share my screen for a minute. Okay. Okay. So right now, we're gonna need, well, we'll use StatDisk. Again, as I've said before, that's my preferred tool. So we have a z-score in the normal distribution. We got to make a probability. So analysis, probability distributions. We're in a normal distribution. So we've got a z-value of 0.26. Click evaluate, and it tells you what you need. Since the question was greater than, we want to the right, and there it is. So the answer is blah, 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 all that. And we just got to double check. Usually they want it to 4 decimal places. So I'm just going to assume they want it to 4 decimal places. So then you'd write down 0.3974. There you go. Go by stat disk. Probability that x is greater than 88.13 is 0.3974, because that was the area to the left. Sorry, the area to the right. It also gives the area to the left, but we don't need that for this question. So that's okay. All right, so there's part A. So now let's get into part B. Part B says a sample of 38 boards is randomly selected. What's the probability that their mean length is greater than 88.13? Okay, so again, this is the problem where we kick it up a notch. So no longer are we asking about individual values per se. We're saying we're going to take a sample and then calculate the sample and then calculate a value from the sample, which in this case is the sample mean. So how do we write this? So what is the notation for a sample mean? So remember, it's important to distinguish between a population mean, which is the mean of everything that exists, versus a sample mean, which is you just take a couple, whatever, a handful, whatever it might be. Okay. So remember that a sample mean is x bar. Okay. So remember that a sample mean is x bar. So what this question is asking is, what is the probability that x bar is greater than 88.13? So when you take a sample, a couple things happen. First of all, you're asking questions not about x, which is an individual data value. You're asking about x bar, which is the value from the sample, which in this case is the sample mean. Second of all, and this is very important, the distribution changes. So this is discussed at great length in the lecture video and all those things. Let me emphasize it again. The distribution, when you take a sample, the distribution changes. Okay, so I'll put new distribution. So in this case, this is the distribution of x bar. Okay, so first of all, what's the shape? So because the original population is normal, the distribution of x bar is also normal. That's the first thing. The second thing, the mean from the original population was 88. So it turns out, this is discussed in more detail in the notes, in the lecture, the mean from the population is 88. Therefore, the mean for x bar is also 88. The mean for x bar is also 88. So you might say, well, what's the big deal? Well, the standard deviation changes. The standard deviation for x bar is not the standard deviation from the population. The standard deviation for x bar is sigma, the standard deviation of the population, divided by the square root of n. N is your sample size. Remember that it said, let's go back up a bit. It said we were taking a sample of 38 boards. Okay, so your sample size is 38. So therefore, the standard deviation for your distribution of x bar, because we're taking a sample, sigma 0.5 divided by the square root of n, so over rad 38. And now you got to calculate this guy right here. So let me just do that in a calculator, 1 second. 0.5 divided by the square root of 38. Okay, that winds up being 0.0811. So I typically like to work to 4 decimal places. That's what I recommend. Okay. So this is why it's super important to write down what your distribution is. When you are taking a sample, your distribution changes. I can't say that enough times, and people always make this mistake. When you take a sample, your distribution is a different thing. In particular, the standard deviation changes. Okay, so now we need to set up the problem anew. So we still have a normal distribution. So the z and the z-score in the middle is 0. Now, what are we looking at the distribution of? These are no longer x values. These are x bar values. Now, what is the mean for x bar? So it happens it's the same as the mean from the population, which is 88. Now, again, we're going to mark off our value of interest, which is 88.13. And we want the probability for greater than, which is to the right. So now we got to get, again, into our calculations. So first we're going to need the z-score, then we're going to need the probability. So z. Now here's the thing. It is no longer x minus mu over sigma because this question isn't about x values. It's about x bar values. So x bar minus mu for x bar over sigma for x bar. And the x bar value of interest, because they decided to use it again, is 88.13 minus the mean for x bar, same as from the population, still 88, and sigma for x bar, well, we calculated all this stuff, 0.0811. So now punch that into your calculator. And you get 1.60. And z-score, I'm going to round to 2 decimal places. You could round it to 4, it'd probably work out about the same. And so we know the z-score is 1.60. And now we just need to punch that in order to find the area. Z, 1.60, click evaluate, and it's greater than, so we want area to the right, 0.0548 if I round. So area to the right was 0.0548. Okay. We also have area to the left, don't need it for this problem. Probability that x bar greater than 88.13 equals 0.0548. So I just took this and just took that and I just rounded it to 4 places. Okay. So that's how to do that question.